Check this out. The sun has been up for 6 hours, and the temperature has already exceeded 50 degrees Celsius. The desert stretches in every direction, just an ocean of sand where nothing grows, nothing moves, and nothing survives for long. The air shimmers with heat, the ground radiates thermal energy like an open furnace, and any mammal caught here should be dead within hours due to dehydration, heat stroke, and organ failure. However, crossing this wasteland, moving at a steady, unhurried pace, is a camel. It has not drunk water in 7 days, its body weight has dropped by nearly a third, and its blood has thickened to a consistency that would kill most mammals through clotting or stroke. The heat beating down on its back should be cooking it alive, and yet it walks. No panting, no desperation, no sign of distress. Just a slow, methodical stride across terrain that has claimed countless lives. When it finally reaches an oasis, it will drink over 100 liters of water in 15 minutes, a volume that would cause fatal water intoxication in nearly any other animal. Its body will rehydrate completely, its blood will thin, its organs will resume normal function, and then it will walk back into the desert as if nothing happened. That is not adaptation, that is biological defiance. Camels break the fundamental rules of mammalian survival. They, frankly, should not work. Their physiology contradicts basic principles of biology, their evolutionary history makes no sense, and their anatomy is a collection of solutions to problems most animals would simply die from. And yet they thrive in conditions that would exterminate almost anything else. This video is about the camel, an animal that evolution designed for a world that didn't exist when it first appeared, and then placed on the wrong continent entirely. Unlike most would think, camels actually did not evolve in the desert. They evolved 50 million years ago in North America, in forests and grasslands that bore no resemblance to the arid wastelands they would eventually dominate. The earliest camel ancestors were small, rabbit-sized herbivores living in temperate woodlands. Over tens of millions of years, they grew larger, developing long legs and specialized teeth for grazing. By 20 million years ago, North America was home to dozens of camel species, ranging from tiny gazelle-like forms to giants larger than modern camels. Then, around 3 to 7 million years ago, something extraordinary happened. Camels crossed into Asia via the Bering Land Bridge, adapting to the increasingly arid conditions of Central Asia and the Middle East. Others migrated south into South America, evolving into llamas, alpacas, guanacos, and vicuñas. And then, roughly 10,000 years ago, camels disappeared entirely from North America. Climate change, competition from other grazers, human hunting pressure, whatever the cause, the continent that gave rise to camels lost them completely. Today, there are no wild camels in the Americas except for their South American relatives, and even those are genetically distinct. Meanwhile, in the deserts of Asia, Arabia, and North Africa, camels thrived. They became the definitive desert animal, so perfectly adapted to extreme heat and aridity that we assume they must have always lived there. But they didn't. They evolved in forests, and by the time they reached the desert, they were already equipped with traits that, by sheer evolutionary coincidence, turned out to be perfect for surviving the most hostile terrestrial environments on Earth. This is evolution's strangest accident, an animal built for one world, accidentally suited for another. Take a look at a camel once and you'll find that every feature seems wrong for a desert animal. A good instance is their fur being thick, dense, woolly, and insulating. Most desert animals have short, sparse fur to shed heat. Camels do the opposite. Their coat can be up to 15 centimeters thick in some areas, but the fur doesn't trap heat. It instead reflects it. Camel fur acts as thermal insulation in reverse, creating a barrier between the scorching external environment and the animal's skin. Studies have shown that sheared camels, stripped of their coats, actually suffer more from heat stress than fully furred individuals, so the fur keeps the heat out, not in. Their legs are also impossibly long, and that isn't an aesthetic choice, it's thermal strategy. By elevating their bodies high above the ground, camels can minimize contact with sand that can exceed 70 degrees Celsius. The air temperature 1 meter above the desert floor can be 10 degrees Celsius cooler than at ground level. That difference is survival. Their feet are also massive, splayed pads that distribute weight like biological snowshoes. Each foot pad can spread to twice its resting size, preventing camels from sinking into soft sand. The pads are also thick and calloused, insulating against scorching ground temperatures that would blister exposed skin. Their eyes are protected by 3 eyelids. 2 are typical, equipped with lashes so long and dense they create a physical barrier against sand. And the 3rd eyelid is translucent, allowing camels to see during sandstorms while keeping their eyes shielded. Their nostrils can also close completely, sealing off the respiratory system during dust storms. But even when open, their nasal passages recover moisture from exhaled air, condensing water vapor and reabsorbing it before it escapes. Every breath recycles hydration. Plus, their mouths are armored. Camels can eat plants that would shred the mouths of most herbivores. Thorns, spines, branches covered in needle-sharp protrusions, you name it. Camels consume them without injury. That is because the inside of their mouths is lined with hardened cone-shaped papillae that crush and manipulate even the most abrasive vegetation. They can eat cacti and can do it casually as if it's normal. None of these facts make sense, and yet all of it works. In the 1990s, scientists studying camel blood discovered something that defied immunology. Apparently, camels produce antibodies unlike any other mammal. Typical mammalian antibodies are Y-shaped proteins composed of 2 heavy chains and 2 light chains. But camels also produce heavy chain-only antibodies, smaller, simpler, and far more stable than conventional antibodies. These antibodies, called nanobodies, are roughly 1/10 the size of standard antibodies. Their small size allows them to bind to targets that conventional antibodies cannot reach. Hidden pockets on proteins, enzyme active sites, and regions inside cells. And they are extraordinarily resilient. Nanobodies remain functional at high temperatures, extreme pH levels, and in the presence of detergents that would destroy normal antibodies. This discovery has revolutionized medicine and biotechnology. Nanobodies are now used in research to study diseases at the molecular level. They are being developed as treatments for cancer, autoimmune disorders, and infectious diseases. In 2018, the FDA approved the first nanobody-based drug for a rare blood disorder. More are in clinical trials. During the COVID-19 pandemic, researchers also developed nanobodies that could neutralize the virus with potency exceeding conventional antibodies. Some formulations could be administered as nasal sprays, offering a non-invasive treatment option. So we see that camels, by accident of evolution, possess an immune system that humanity is now exploiting to fight diseases camels have never encountered. The universe does indeed have a sense of humor. Another interesting fact you need to know about camels is that camels are not gentle. During mating season, for example, male camels inflate a large pink balloon-like organ called a dullah, which protrudes from the side of their mouths. They gurgle, bellow, and drool profusely, coating themselves in saliva to attract females. The smell is reportedly unbearable, like a mix of rotting vegetation and fermented bodily fluids. Males then become aggressive, fighting rivals with bites, kicks, and attempts to knock opponents off balance. They have been known to kill each other in these battles. Camels also have long memories, particularly of mistreatment, as there are documented cases of camels attacking their handlers years after being abused, seemingly holding grudges. They remember faces, they remember injustices, and when provoked, they spit. But what they spit is not saliva. It is rather a mixture of saliva and partially digested stomach contents, regurgitated and expelled with remarkable accuracy. The substance is foul-smelling, acidic, and difficult to remove, and they can hit targets several meters away. All these go to show that the camel is not a prey animal. It is an animal that refuses to be dominated. Today, the global camel population stands at approximately 35 million individuals, almost all of them domesticated. But wild camels are quickly vanishing. The wild Bactrian camel, for instance, is critically endangered. with only 950 individuals remaining. These camels live in the Gobi Desert, one of the harshest environments on Earth. And unlike their domestic relatives, wild Bactrian camels can drink salt water, tolerating saline concentrations that would poison other mammals. They are ghosts in a desert most humans will never see, and they are running out of time. Meanwhile, in Australia, camels have become an ecological disaster. Camels were introduced to Australia in the 1840s to aid in desert exploration and transportation. When mechanized vehicles made them obsolete, they were then released into the wild. With no natural predators and vast arid landscapes ideal for their biology, the population exploded. Today, there are an estimated 1 million feral camels in Australia, the largest wild camel population on Earth. They are now destroying native vegetation, depleting water sources, trampling fragile ecosystems, and outcompeting native species. During droughts, they invade human settlements, breaking infrastructure in search of water. This got so bad that in 2009, the Australian government authorized a mass culling, shooting thousands of camels from helicopters. This illustrates the double-edged nature of extreme specialization. In their native range, camels are irreplaceable, but in ecosystems unprepared for them, they are catastrophic. In the end, as we've seen, camels are not normal mammals. They do not follow the rules of hydration, thermoregulation, or immunology that govern other animals. They evolved in the wrong place, migrated to the harshest environments on Earth, and thrived by being biologically extreme. Yet in a warming world, that extremism may be their greatest strength. As deserts expand and temperatures rise, animals adapted to temperate climates are struggling. But camels, already engineered for heat and aridity, are well positioned to endure what is coming. They are not fragile, they are not delicate. They are survival incarnate, shaped by millions of years of evolutionary accidents into creatures that can withstand conditions most life cannot tolerate. Camels don't make sense because they were never supposed to. They are the result of evolution solving problems in the most extreme ways possible. And in doing so, they became irreplaceable. If you want to explore more animals that break the rules of biology and thrive in worlds that should kill them, subscribe and join us as we uncover the extremes where evolution creates the impossible.